Modular programming breaks a large program into smaller, independent modules, ensuring that changes in one module have minimal impact on others. This approach promotes code reuse. As long as a module's interface remains unchanged, updates to that module will not affect the rest. Modules are compact and easier to manage, and they can sometimes be divided into submodules. In LabVIEW, a subVI serves as a module, and it is a VI embedded within another VI and is designed for reuse. Any LabVIEW VI can function as a subVI. In this example, two identical sections of code are shown, which can be replaced by a single subVI for efficiency. The simplified version demonstrates how the subVI substitutes the repeated code in the block diagram. A subVI in LabVIEW is comparable to a function in C. Just as you call a function in C, you can use a subVI in a similar way. You can create a subVI directly from existing LabVIEW code. To do this, select the portion of code on the block diagram that you want to convert. Then go to the menu and choose Edit, Create subVI. This generates a new subVI. Each subVI has an icon, which is a graphical representation of the VI and should visually convey its purpose or function. For example, an icon might indicate that the VI is related to temperature measurement. Icons help identify subVIs within the block diagram. Well-designed icons clearly reflect the VI's functionality, whereas default icons in LabVIEW typically provide no meaningful information. This icon suggests that the subVI is associated with temperature measurement. To customize the icon, open the icon editor by right-clicking the icon and selecting Edit Icon from the shortcut menu. The icon editor provides tools for customizing your icon. It includes graphic editing features similar to those found in Photoshop, allowing you to create layers for more detailed designs. Additionally, it offers a glyph library where you can search for and incorporate graphic elements into your icon. The connector pane maps objects from the front panel and is located next to the icon. You can change its layout by right-clicking the pane and selecting a pattern from the available options. The pane supports up to 28 connectors, but not every front panel object needs to be linked to it. This represents a standard connector pane layout. To map elements, use the wiring tool, which should be automatically selected when it hovers over a connector. First click the connector, then select the corresponding object on the front panel. After mapping, any data wired to the connector is passed to the linked control, and data from the linked indicator can be accessed through the connector. It is recommended to divide the connector pane into two equal sections, inputs on the left and outputs on the right. Use the bottom connectors for error cluster input and output, and reserve the top connectors for reference input and output, such as a file reference in file operations or a task reference in data acquisition. Always document the block diagram for clarity. You can add a free label anywhere on the diagram, preferably close to the code being described. To insert a free label, double-click on the block diagram and type your text. Alternatively, you can use an object label by right-clicking the object and enabling the label as a visible item. Proper documentation of a VI is essential. To add or edit VI documentation, open VI Properties by selecting File, VI Properties, or by right-clicking the VI icon and choosing VI Properties from the menu. Then navigate to the Documentation section. The text you enter here will appear in the Context Help window. For front panel objects, use the Documentation tab in their Properties. The description field explains the object's function, while the tip strip provides a short message that appears in a yellow pop-up when the cursor hovers over the object. There are several ways to use a subVI in LabVIEW. You can drag and drop the subVI from the project file into the calling VI. Another option is to use the quick drop feature by pressing Ctrl+space, typing the subVI name, and then dragging it into the calling VI. You can also access the function palette, choose the option, select a VI, from the pop-up menu and locate the VI by browsing to its file location and drag it into the calling VI. Finally, you can simply drag the subVI icon into the calling VI. LabVIEW VIs have three types of terminal settings. Required terminals must be wired, otherwise, the calling VI will break and fail to run. These terminals appear in bold in the context help. Recommended terminals use a default value if not wired, 0 for numeric, false for Boolean, and an empty string for text. You can set a custom default by entering the desired value on the front panel, right-clicking the control, selecting Data Operations, and choosing Set Current Value as default. Optional terminals behave similarly to recommended terminals, but are rarely used. A common subVI design pattern involves wrapping the code in a case structure controlled by the error cluster input. If there is no error, the subVI executes normally. If an error exists, the code is skipped, and the error is passed to the next VI. This approach ensures proper error handling without processing errors inside the subVI. Avoid using built-in LabVIEW error handler VIs within subVIs. Always forward the error to the next VI for specialized handling. In this demonstration, we will create a LabVIEW subVI that simulates the digit pattern of a 7-segment LED. Begin by creating a new VI and arranging the front panel and block diagram side by side. A 7-segment LED consists of 7 bars labeled from A through G. To light up a specific segment, wire a Boolean value of true to its corresponding LED indicator. The subVI will output an array of 7 Boolean values, each representing the state of one segment. The objective is to design a subVI that takes a single digit as input and returns its LED pattern. On the front panel setup, add a numeric control named digit and set its representation to I32. Add a Boolean array indicator named pattern. Add error in and error out clusters for error handling. On the block diagram, select all terminals, right-click, and uncheck View as icons. Arrange the control terminals on the left and the indicator terminals on the right. Insert a case structure on the block diagram. Connect the error in cluster to the case selector. Then, wire the error cluster from the selector to the right side of the case structure. Create an output tunnel and link it to the error out indicator. Add a 10 by 7 two-dimensional Boolean array representing LED patterns for digits 0 to 9. For example, digit 0 lights segments A to F and leaves G off, while digit 1 lights only segments B and C. Continue this pattern for all digits. Move the digit terminal inside the case. Insert an index array function. Wire the Boolean array constant to its array input and the digit terminal to the row index input. Connect the function's output to the right side of the case. Create an output tunnel and link it to the pattern terminal. In the error case, right-click the pattern output tunnel and create a constant Boolean array and expand it to show 7 elements. To set all 7 values to false, click the last value twice. This ensures that no LEDs are lit if an error occurs before the subVI runs. Connect the case selector and the error cluster tunnel on the right. Next, customize the subVI. For the icon, open the icon editor and remove the default design. Choose a template with a title bar and fill it with blue or any preferred color. For consistency, use the same title color across all subVIs in the project. Add the text LED in white on the title bar. Then use black to draw a 7-segment LED graphic on the icon. For the connector pane, keep the default layout. Assign the error clusters to the bottom connectors and map the remaining 2 objects to the top connectors. For documentation, in VI Properties, select Documentation and provide a description that explains the subVI's purpose. Inputs and outputs. This description will appear in the Context Help window when enabled for additional clarity. Finally, save the subVI as getLED to VI. Let's create a host VI to test the subVI. Start by creating a new VI and arrange the front panel and block diagram side by side. On the front panel, add a numeric control named value and set its representation to I32. Add an error in control on the front panel. Insert a square LED on the front panel. Open its properties, go to the Appearance tab, and set its size to 15 in height and 60 in width. Duplicate this LED twice to create additional 2 horizontal segments. Add another square LED. Open its properties and set its size to 60 in height and 15 in width. Duplicate this LED 3 times to create additional 3 vertical segments. Arrange the 7 LEDs to resemble a standard 7-segment display. Rename the LEDs from A to G according to the 7-segment layout and adjust their label locations. Select all terminals on the block diagram. Right-click and uncheck View as icon. Rearrange the LED terminals and their labels for better wiring later. Use alignment tools for precise positioning. Right-click to open the Functions palette and choose Select a VI. Pick the subVI getLED and drop it on the block diagram. Wire the error in terminal to the error in connector to simulate an error condition before calling the subVI. Wire the value control to the digit input of the subVI. Add an array to cluster function to convert the subVI's pattern output into a cluster. Alternatively, you can use the index array function. Insert an unbundle cluster function and wire it to the cluster output. Connect each unbundled Boolean value to the corresponding LED. Enclose the code in a while loop and add a stop button to control execution. Wire error out connector to the right edge of the loop and create an output tunnel. Add the simple error handler VI and connect it to the error output for software error handling. If you turn on the context help, you can view the VI documentation when you hover the cursor above the subVI icon. When the cursor is above the connectors of digit control and pattern indicator, you can also see the tip strips. Run the VI and change the digit value to observe the 7-segment LED display. If you mark error in the error in control, all LEDs will be turned off. This completes the demonstration.